this section we are going to start the IPv6 addressing scheme. Actually, IPv6 is more complicated than IPv4 because I have already shown you to run the ipconfig command, where you will see the IP address simply looks like something different. Oh my god. Here when I will run the ipconfig and all command, so you can see here the IPv, this is actually the IPv address is IPv6. This is the IPv6. Okay, and this is the IPv4. So in this section we are going to discuss about the IPv6 addressing scheme. Previously we will discuss about their difference between the match, what is the difference between the IPv4 and the IPv6. The IPv4 having the size is 32-bit, all of us know. So the total of number of the IP address is to the power 32 minus 2. Okay, but this is the total size is 128-bit. So the total size is 128. So this is very number of the IP addresses. So this type of the actually not is the sufficient for the allocation. That is the reason the IPv6 is in the market. Mostly it is cope with the mobile IoT growth, because right now I am using the hotspot. That is the reason I am getting this IP address to my laptop, because this is also getting the IPv6. Generally, mostly using the, like there is a lots of the growth of the IoT devices or the smart devices. So the 32-bit size or the IPv4 is not enough to cover all the device or cover or provide the identity to all the device connected in the network. That is the reason IPv6 in the market. Hierarchical address allocation, and this is having the simple routing table. So actually routing table is a type of the table which is providing the route to the packet, where packet to travel. Okay, so IPv6 has a simple header, it have the main header, it is called also the extension header, which can be extend. Key fields can be used the traffic class, flow label, payload length, next header and hop limit. Actual payload length, when we talk about the zombie packet, means the packet can be maximum is 4 GB, and in a IPv4 there is a total maximum size is 4096 bytes, if you remember, but here zombie packet can be 4 GB maximum. And also provide the hop count, how many hops are connected, and there is a limit of the hops are connected inside the network. Hops means one router to another router, another router to another router, another router to another router. So all the router will be considered as a hop. And the address format is there from starting from here and leaving from here, and total size is 128-bit. But this is not written in a numeric value. Numeric value are not used in a IPv6. So which value or which notation is used? Hexa notation. It is called hex notation. Means hexadecimal value. All of you know about the hexadecimal value? Actual decimal means 0 to 9, any number. It is called decimal. When the hexa is added, hexa means 6 will be added more. 6 is 0 to 9, then A, B, C, D, E and F. 6 value. So it is sometime you have written like this 2001. It is looks like decimal. And 0 dB, dB 8, it looks like this hexadecimal. You cannot use the XYZ because XYZ actually not within the range of the hexadecimal value. The hexadecimal value is the range from the A to F only. So arrange the hexadecimal means in A1. You can see there is a one similar as a octet, one part 1, 2, 3, 4, 5, 6, 7 and 8. The total part is 8 and one part is size is 16 is equal to 128. 16 bit. Every part is considered 16 bit. In a IPv4 there is a one octet value was 8 bit. But here is a double quotation used like this, double colon, and it between the value is 16 bit, means 16 bit here, 16 bit here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16 means the 4 bit is equal to one character of the hexadecimal value. Like it is 0, 0 to E. 0 to E, 1 bit is equal to 4 bit. 4 bit, 4 and 4. Total bits are 16. Similar here, similar here, similar. It's some, maybe in the starting it is looks like the complicated, but this is easy to remember. Can you see this is actually the number of the IP address? This is IP address to the total value. So it will take a lots of the time. It will take a lots of the time. 2001 double dot 0 db8 double dot 0000 double dot abc 0000 df0 1 2 3. So there is some possibilities, or there is some facility or the feature. It is called canonical notation, or you can see canonical means compression, compress of this IP address. So how you can compress? The simple is omit leading zeros will be removed. Omit leading zero. Omit leading means 005 can be written as a 5. 500 is cannot be written 500. Keep in mind, omit only leading 0 will be removed. So here is leading 0. Is it leading 0? No. Is it leading 0? Yes. These are leading 0? Yes. These are leading? Yes. This is leading. This is leading. This one? No. There is a no 0. So what you will do, you will remove this 0. So means 20 db8. Now you will write like this, 2001 db8 0 0 abc 0 def 0 and 1 2 3 4. All these all the 0 has been removed, only 1 0 are there. Similar happened with this. But also you can compress one sequence of all zeros with double bytes. There is a sequence of the all zeros, so you can remove these zeros as well and put the simple double quotation. But this double quotation you can use only one time. You cannot use again. Only one time you can use. Means you cannot remove this 0 and put the 0 here. So this is the compression of the IP address. Means you can compress the IP address by using two conditions, omit leading and the sequence of all zeros. Sequence all our zeros be double quotation and omit leading 0 will be removed. So now it is compressed. This looks like little bit easy, but not as easy as we think. To providing the IP address but you are not providing IP address by your own. You can use the DHCP server, that's it. DHCP server will take care of all.